So today we're going to talk about notes on volume. So that should say on, not of. So volume. So first off, volume is a measure of space that's occupied by a figure. In other words, volume fills the figure. Now when measuring volume, the units will be cubed. So that's very important to remember. So it's going to be inches cubed, centimeters cubed, or just simply units cubed if we don't know the exact units they used. Now, first we're going to talk about volume of a rectangular prism. So we're always going to multiply the area of the rectangular base, so please add an E there, which is length times width, by the height. So our formula is V is equal to length times width times height. Now if we look carefully at the first example, so find the volume of the prism. So we have 5, 4, and 10. So we can designate this simply to be our length, our width, and our height. Okay, so the first thing we know is our formula is going to be length times width times height. So substituting that in, I have a length of 5, a width of 4, and a height of 10. Just multiply it all together and we get 200 centimeters cubed. Remember to cube our answer. So all we did was just multiply our length, our width, and our height. And here it does not necessarily matter which one you designate as length, width, and height, as long as you are consistent and when you label them and you plug them in the correct spot. So let's look at example 2. So this example, all they did was to take this rectangular prism, or any rectangular prism, and flatten it out. Like for example, flattening a cereal box, and taking it apart at the edges and flattening it out. So here in green we have 5, in blue we have 3.1, and then in red we 7.4. So these are the three measurements we have. So we know we're going to do 5 times 7.4 times 3.1. Now remember, it doesn't necessarily matter which one's your length, width, or height, as long as you're using all three measurements. So multiply those three together and you get an answer of 114.7 centimeters cubed. Okay, so this is if we had a net. So then we identify the three different measures. Now let's look at example 3. So here we're trying to figure out how much cereal can this box hold. So how much cereal we can fill the box with. So that's going to be a volume. So here we know, that we have 6, 2, and 9. So the first thing we're going to do is find the volume. So I have 6 by 2 by 9. Multiply those three numbers together and you get an answer of 108 inches cubed. Remembering to cube our units here. Now, example 4. So you're going to use the cereal box from the previous question. A family size cereal box is created by tripling the width. That's very important that we notice that. How much cereal will fit in the new family size box? So they're taking this box that we have in example 3, and tripling the width. The width here happens to be 2 inches. We just picked 2 to be the width. So if I'm going to triple that, that means it's going to be 3 times bigger than 2 inches. So that means our 2 inches now goes to 6 inches. And all we simply did was take that width of 2 and multiply it by 3, because that's what tripling means. So now we're going to use width of 6. That's the only one that changed, but we're still going to use the height of 9 and length of 6. So we still have a length of 6. Our new width is 6, because we did 2 times 3, and our height is 9. So the new cereal box, for the family sized box, would be 324 inches cubed. So this type of example where you could see in example 3, that cereal box being sold at Giant, and then in example 4, the size you would get at a wholesale store like Costco. Now, going to examples 5 and 6. So here, question 5 is asking us how much water we would need is needed to completely fill this pool. So we have this swimming pool, we want to know how much water needs to go inside. So here, we know the pool is 14 feet by 12 feet with a depth of 4 feet. And remember, depth and height interchangeable here. This time it's deep and not necessarily above. So for height. So we're going to do 14 times 12 times 4. Once you get that, you get an answer of 672 feet squared. Now let's go ahead and fix that. okay? Excuse me, feet cubed. Now, the next part's asking what would the volume be if the pool is only half full? So here the key word is half full. So if I want to find half of something, I can simply divide by 2. So here I take the 672 we found in problem 5, divided by 2 to get an answer of 336 feet cubed. Now we can think about it and see if we were to ask a fourth full, we could simply just divide by 4. A third full, we could divide by 3. Okay, so it's by that denominator in those fractions. And we don't have to do anything else because the numerator was 1. So let's go ahead and look at the next side. So we have now cylinders. So the volume of a cylinder, we're going to multiply the area of the circular base, which is pi r squared, by the height h. So our formula simply is pi times the radius squared times the height. Now, looking at example 1, we're going to identify the radius and the height. Remember, the radius is only from the center of the circle to the outside to the circle, not all the way across. That would be diameter. So in this case, radius is equal to 2 centimeters, and our height of our cylinder is equal to 5. So, using the formula we have up here, pi r squared times h, we're going to use 3.14 for pi times 2 squared times 5. Now remember, we need to square the 2 first before multiplying anything else. So that would change this equation to 3.14 times 4 times 5, and the 4 came from the 2 squared. So now multiply those 3 numbers together and you should get an answer of 62.8 centimeters cubed. Alright, looking at example 2. So to find the volume, we need radius and height. Well, we know the height is going to be 2, and this is just a flattened out image of that cylinder. So here they give us a dashed line all the way across, which is 6. So we know that's diameter, and we're not looking for diameter, we want to know the radius. So the radius is just half of that, so it would be 3. So, plugging it in, we have 3.14 times 3 squared times 2. Remember to square that 3 first, and that's where we get that 9. So now we can multiply 3.14 times 9 times 2. So go ahead and multiply those 3 numbers to get an answer. We should get an answer of 56.52 centimeters cubed. So let's go ahead and look at some more examples. So example 3, we want to find the volume, and all they did this time is take the cylinder and turn it on its side. So our height is still 12 and our radius here is 4. So we know we have 3.14 times a radius of 4 squared times 12. Okay? And we want to square that 4 first. So 3.14 times 16, which is 4 squared, times 12. Now we can multiply the 3 numbers together to get our final answer. Multiply 3.14 times 16 times 12, we get an answer of 602.88 centimeters cubed. Don't forget to cube those centimeters. Now, example 4, we have from the top to the bottom it says 12, and from one side of the circle to the other is 10 centimeters. Now we can tell that the height is 12 centimeters. But we need to be careful because the radius is not 10. Okay? The radius would only be half of it, meaning 5 centimeters. So the first step is to plug in our values. We're going to use 3.14 for pi, 5 for our radius squared, times 12. Remember to square your radius first. So now we get 3.14 times 25 times 12. Now we can simply just multiply our 3 numbers together to get our final answer. Once we multiply, we get an answer of 942 centimeters cubed. Next, we want to figure out how much pineapple juice can this can hold. Now see here, this top line shows us that the diameter is 6 centimeters, meaning our radius is 3, because remember we just cut that in half. And so our height of our can is 9 centimeters. Substituting in our values first, 3.14 times 3 for the radius squared times 9 for the height. Remembering to square our 3 first, so 3.14 times 9 times 9. Multiply those 3 numbers together, you get a value of 254.34 centimeters cubed. Now, example 6 tells us that we want to determine how much soda is in this can if it has a height of 5 inches and a radius of 1 inch and is exactly half full. So, 2 steps to this. First, let's find the volume of what this can hold, and then we'll determine how much it would be if it's exactly half full. Now, see on my smartboard, I've already drawn the dimensions. It's helpful to draw on your pictures. So here we know the height's 5, so from top to bottom that's 5, and the radius is from the center to the edge is 1 inch. So plugging that in. So we have 3.14 times a radius of 1 squared times 5. And simply we know 1 squared would be 1, so this turns into 3.14 times 1 times 5. Now our next step here, okay, will be, we get 15.7. Since it's half full, we need to divide by 2. So once we do that, we get an answer of 7.85 meters cubed. So just a few more questions. So at the bottom here, we wanted to select all the situations that would require finding the volume. So we're going to find the volume here. Okay. So we are going to see the amount of coffee a mug can hold. So that's trying to ask how much coffee can go inside your mug. So since we're trying to figure out how much it takes to fill it up, that is volume. The amount of cardboard to make a cereal box. Well, cardboard is only on the outside of the cereal box, so not how much goes inside. So that would not be volume. How much oatmeal can be contained and that should say in Tupperware. Okay, so here, how much oatmeal can fit inside a container. So that is volume. The next problem says the amount of paint needed to cover a chest. And since here we're just saying covering and not filling, that is once again just the outside, and volume determines the space inside. So that is not volume. How much water in a half-filled bath? So even though we're only filling it halfway, we're still filling the bathtub, and that is volume. And simply we could just divide the volume by 2 to get half of it. And the amount of space inside a chest. So since it says inside a chest and it's the space, we know that's going to be volume. So go ahead now, work on the practice.